Imagine a molecule born in a dusty lab back in 1876. It wasn't designed to revolutionize biology. It was created to color drapes, and eventually, the world's first pairs of blue jeans. It's a synthetic dye, a simple chemical curiosity. Now, picture that same molecule over a century later being hailed as one of the most potent biohacks available, capable of rewiring our fundamental cellular biology. Sounds like science fiction, doesn't it? Well, sometimes the most profound discoveries aren't found in a futuristic lab, but hiding in plain sight in the pages of old chemistry books. We're talking about methylene blue, and while half the internet thinks it's a new boutique paint color, and the other half thinks it's some magic drink that just gives you colorful urine, the truth is far more fascinating. This humble dye has been quietly outperforming overpriced supplements and flashy biohacks since before your great-grandfather learned to shave. Hi, I'm Dr. Mike, and today we're pulling back the curtain on this incredible compound. But before we dive deep into the biochemistry, let's get the crucial part out of the way. This is not meant to treat, diagnose, cure, and is purely for entertainment. Research peptides are not for human or veterinary use. Use extreme caution when entering the gray market and arm yourself with knowledge. Now, let's talk about the master shapeshifter of the biological world. Methylene blue is what's known as a redox chameleon. In the language of biochemistry, that means it can flip between an oxidized state and a reduced state with breathtaking speed. And that simple trick is the key to unlocking its extraordinary power within our cells. To understand how it works, we need to take a trip inside one of your trillions of cells, to the engine room of life itself, the mitochondria. These are the little power plants that fuel every single thing you do. From every heartbeat and every breath to every thought you have trying to remember your Wi-Fi password, it's all powered by these microscopic reactors. Most of us, however, are casually abusing them daily with late-night meals, chronic stress, and not enough sleep. Inside each mitochondrion is the electron transport chain, or ETC. Think of it as a biological bullet train. Its job is to move electrons at high speed through a series of 4 protein complexes, creatively named complex 1, 2, 3, and 4. As these electrons travel, they create enough energy to pump protons across the inner mitochondrial membrane. This creates a powerful gradient, like water building up behind a dam. It's this proton gradient that is the source of our energy. At the end of the line, these protons rush back through a molecular turbine called ATP synthase. This incredible motor spins at thousands of RPM, minting the energy currency of our body, ATP. You produce and use roughly your own body weight in ATP every single day. But here's the problem. Modern life loves to create gridlock in these power plants. Stress, toxins, poor diet, and lack of sleep can cause a traffic jam. Complex 1 gets clogged with things like reactive oxygen species, or ROS, which are like metabolic exhaust fumes. Further down the track, excess nitric oxide can come in and effectively shut down Complex 4. Now you've got a multi-car pileup. The entire assembly line grinds to a halt. The result? The proton gradient weakens, ATP production plummets, and more metabolic garbage, like superoxide radicals, starts piling up. Your cellular power grid experiences a brownout. You feel it as fatigue, brain fog, and inflammation. This is where methylene blue enters the scene, not as a tow truck, but as a lane-splitting motorcycle courier on a mission. It performs a brilliant biological shortcut. Methylene blue has the unique ability to accept electrons from NADH right before the blockage at complex 1. It essentially says, I'll take that package for you. Then, full throttle, it bypasses the entire traffic jam, the whole messy gridlock of complexes 2 and 3, which are caught in the backup. And it delivers those electrons directly downstream to complex 4. The delivery is complete. The bullet train is back on track, and the proton pump starts churning away again. By restoring this flow, methylene blue keeps the proton gradient strong, ATP production high, and it dramatically reduces the collateral damage from that toxic superoxide fallout. It keeps the lights on. And the most elegant part? It's a perpetual motion machine. After donating an electron, it becomes colorless, or reduced. It then gets reoxidized by oxygen, turns blue again, and is ready to jump back into the fray to shuttle another electron. It's a self-recharging molecular battery. Now, let's consider where this matters most. Meet your neurons. They are the energy divas of your body. Your brain makes up about 2% of your body mass, but consumes a whopping 20% of your oxygen and energy budget. They burn through ATP like a fighter jet burns through fuel. So, when that mitochondrial gridlock happens, neurons are the first to suffer. They lose their membrane potential, neurotransmitter release sputters, and your brain starts to feel like an old smartphone that's frozen and throwing error messages. Methylene blue restores that critical electron flow, stabilizing the mitochondria in your brain cells. This allows for steadier, smoother synaptic firing. The result is a level of mental clarity that can make a triple espresso feel like a placebo. But it doesn't stop there. Methylene blue also acts as a mild and, importantly, reversible monoamine oxidase inhibitor. MAO is the enzyme that acts like a repo man for your feel-good neurotransmitters, taking them away before they can do their job. By gently dialing down MAO, methylene blue allows serotonin, dopamine, and norepinephrine to linger longer. This translates to a more stable mood, sharper focus without the jitters, and a feeling of steady, driven energy. This neurological support has profound implications. In research settings, it's being studied for its ability to interfere with the formation of tau proteins, which are implicated in conditions like Alzheimer's. For challenges like Parkinson's, it's seen as a potential lifeline for dopamine neurons, helping to clear out damaging protein clumps and toughen up the mitochondrial armor, which may help with motor control. This cellular rescue mission has system-wide effects. Think about your endocrine system. Chronic oxidative stress is like a never-ending soap opera for your hormones. Cortisol spikes, insulin sensitivity tanks, and thyroid hormones go on vacation. By muting that oxidative chaos at the mitochondrial level, methylene blue helps calm the whole hormonal melodrama. The perpetually screaming HPA axis gets rewired. Cortisol levels can normalize, and insulin receptors stay sharp. For women, this can mean nudging estrogen metabolism towards a more protective pathway, potentially easing the inflammatory storms of PMS and menopause. For men, it can help maintain the cellular vigor needed for healthy androgen production. And what about performance? In a fascinating twist, methylene blue can also act as an alternative electron acceptor, just like oxygen. This is a game changer for aerobic capacity. When you're at high altitude, on a long flight, or pushing your endurance limits, oxygen becomes a scarce resource. Methylene blue can step in, allowing your mitochondria to keep producing energy even in low oxygen states. This can extend endurance and make you more resilient to hypoxic stress. For anaerobic athletes, this means potentially faster recovery between sets. By supporting the aerobic system's ability to come back online, it can shorten rest periods and increase work capacity. Now, after hearing all of this, it can be tempting to think of this as a miracle cure-all. But this is where we need to apply a heavy dose of caution and intelligence. Using this compound correctly is just as important as understanding what it does. First and foremost, purity is everything. There is a universe of difference between pharmaceutical-grade methylene blue and the industrial-grade dye used for textiles or lab stains. They share a name, but that's where the similarity ends. The manufacturing process for industrial dye can leave it contaminated with heavy metals like lead, arsenic, and mercury. These are mitochondrial poisons. Taking contaminated methylene blue is like trying to put out a fire with gasoline. It's non-negotiable to source from a reputable supplier that provides a third-party certificate of analysis, or COA, proving it's free from these toxins. Second is the dosing strategy. The mantra is start low and go slow. Because it directly impacts energy production and neurotransmitter levels, responses are highly individualized. A beneficial dose for one person could be wildly overstimulating for another. A typical starting point for experimentation is in the very low range, perhaps 2 to 8 milligrams per day. From there, one would titrate up slowly over days or weeks, paying close attention to the body's response. What are the signs of too much? Feeling shaky, a racing heart, or the kind of overstimulation that feels like you drank an entire pot of coffee? If that happens, it means the dose is too high for your system. Third, and this is critically important, are contraindications. Because of its MAO inhibiting properties, methylene blue should never be combined with SSRI or SNRI medications or other MAO inhibitors. The combination can lead to a dangerous condition called serotonin syndrome. Additionally, individuals with a genetic condition called G6PD deficiency should avoid it, as high doses can cause a serious breakdown of red blood cells. Finally, consider the form. Bioavailability can vary. Simple powder in a capsule may have significantly lower absorption compared to liquid forms or troches designed to be absorbed in the mouth. So why isn't this amazing molecule being shouted from the rooftops by every major health company? The answer is simple and a bit cynical. You can't patent a century-old chemical. There's no billion-dollar marketing campaign because there's no blockbuster profit margin. It hides in plain sight while people spend fortunes on designer nootropics that barely outperform a good night's sleep. We live in a culture that often assumes if something isn't backed by a Super Bowl commercial, it can't be valuable. We ignore proven, decades-old science because it doesn't come in a glossy influencer package. Methylene Blue is a testament to the power of biochemistry. It turns mitochondrial gridlock into an open highway. It gives your neurons fiber optic bandwidth and tells chronic fatigue to take a hike. It is a profound tool. The real takeaway isn't just about a single supplement, it's a challenge. To stop renting your understanding of your own biology from the loudest advertiser. It's about digging into the science, respecting the mechanisms, and arming yourself with the knowledge to make informed decisions. Pair a tool like this with a deep understanding of your own biology, and you create a system that is resilient, high-performing, and built to last. You don't just survive, you thrive. If you found this information valuable, please support the channel by liking this video and subscribing for more content on the cutting edge of health science. Every click helps us continue to bring this kind of deep dive education to you. And don't forget to sign up for our newsletter using the link in the description below. It's the best way to stay updated and get exclusive content delivered right to your inbox. Thanks for watching. Let's circle back to the core concept of the electron transport chain. It's a cascade, a series of handoffs. NADH, which is derived from the food you eat, fats and carbohydrates, arrives at complex 1 ready to donate its electrons. Think of NADH as a fully charged delivery truck. When it donates its electron package to complex 1, it becomes NAD+, an empty truck ready to go back to the Krebs cycle to pick up another load. This recycling of NAD is fundamental to energy production. When complex 1 is dysfunctional, that recycling process breaks down. NADH trucks pile up, unable to unload. This is a critical point that Methylene Blue addresses. By accepting those electrons, it helps regenerate the NAD+ pool, keeping the entire metabolic factory running. At the very end of the chain, after all the proton pumping work is done, the spent electron needs a final place to rest. That place is oxygen. Oxygen is the ultimate electron acceptor, which is why we need to breathe. Without it, the entire chain backs up instantly. The reactive oxygen species we mentioned earlier are essentially electron leakage. When the chain is slow or blocked, electrons can escape prematurely and react with oxygen to form superoxide. These are the sparks that can start cellular fires, damaging proteins, lipids, and even your DNA. Methylene Blue's ability to keep the chain moving smoothly is its primary antioxidant effect. It prevents the fire from starting in the first place. But at low doses, it can also act directly, picking up these stray free radicals, further protecting the cell from damage. It's interesting to note that at very high doses, methylene blue can become a pro-oxidant. It can actually generate some ROS on purpose. This isn't always a bad thing. In certain contexts, like fighting infections, this pro-oxidant effect is what gives it antimicrobial power. But for daily wellness, it's the low-dose antioxidant and electron shuttling properties that are most desirable. The increased efficiency in your neurons has a cascading effect. With more ATP available, brain cells can maintain their functions more effectively. This leads to improved cerebral blood flow and better oxygen utilization, creating a virtuous cycle of brain health and peak performance. The MAO inhibition also occurs in the gut, which is often called our second brain, and is a major producer of serotonin. By supporting neurotransmitter balance in both the brain and the gut, you're fostering a more resilient HPA axis, the central stress response system. While it can be stimulating, some individuals find that a very low dose of methylene blue can support sleep. Sleep, especially REM sleep, is an incredibly energy-intensive process for the brain. By providing the mitochondria with efficient fuel, it can potentially support the restorative processes that happen overnight. As a fascinating piece of trivia, the only cells in your body that do not contain mitochondria are mature red blood cells. They jettison them during their development to make more room for hemoglobin, the molecule that carries oxygen. Every other cell relies on this intricate energy-making machinery. The benefits of reduced oxidative stress extend everywhere. Better mitochondrial function supports DNA repair mechanisms. This can translate to things like improved wound healing and healthier skin, as the collagen factories are shielded from oxidative damage. It can even act as a shield for your retinas. The eyes are incredibly metabolically active and vulnerable to oxidative and pressure-related damage. Supporting mitochondrial health in the retinal cells is a key strategy for long-term vision health. We mentioned how methylene blue mops up excess nitric oxide. This is crucial in emergency situations like septic shock, where runaway vasodilation causes a catastrophic drop in blood pressure. By restoring balance, it can be a life-saving intervention in a hospital setting. Its synergy with red light is another fascinating frontier. When activated by light at a wavelength of 660 nanometers, methylene blue becomes a potent photodynamic agent. This is being explored as a non-antibiotic way to address localized infections, from the sinuses to the bloodstream. Let's reiterate the dosing protocol, as it's the most common area of confusion. The goal is to find the minimum effective dose. For some, that might be a few milligrams every other day. For others dealing with a higher stress load, it might be up to 25 milligrams. It doesn't necessarily need to be taken every single day. Many find success using it cyclically, or on days when they need extra cognitive or physical performance, such as before a big presentation, a strenuous workout, or a long-haul flight. For jet lag, it's a phenomenal tool. Taking a dose before, during, and after a flight can help mitigate the triple threat of hypoxia from the cabin pressure, oxidative stress from radiation at altitude, and the general fatigue of travel. And yes, it will most likely turn your urine blue or green. This is normal and simply means your body is excreting the oxidized form of the molecule. Sometimes, on a day where your body is under more oxidative stress, your urine might be its normal color, even with the same dose. This is because more of the molecule was used in its reduced, colorless form to donate electrons. This isn't about chasing a high or a quick fix. It's about providing your biological system with a tool that allows it to run closer to its true potential. It's about restoring the fundamental process of energy creation that underlies everything else. The responsibility falls on the user to be discerning. In an unregulated market, you must demand transparency. If a company cannot provide a recent third-party COA for heavy metals, you must assume the product is not safe for consumption. Full stop. When used correctly, the effect can be like flipping a switch. The mental static fades, the cognitive horsepower comes online, and the physical energy is there when you need it. It's a return to a state of cellular efficiency that many people haven't felt in years. The story of methylene blue is a powerful lesson. It reminds us that profound solutions can be simple, elegant, and sometimes they've been with us all along, waiting for us to reconnect the dots of modern science with the discoveries of the past. Your body is an intricate machine. By supporting its most fundamental gear, the production of energy in the mitochondria, you enable the entire system to function with greater harmony and resilience. Stay curious, do your research, and prioritize your health with intelligence and care. Thank you again for joining this deep dive. We'll see you in the next video.